Hi, it's Jan Beta, and I have my Amiga 500 set up here running Monkey Island, as you can see, and currently I have it hooked up through the original RGB output running to my OSSC upscaler that converts the signal to an HDMI signal, which can then be displayed by my modern-ish monitor here, and it looks rather good. Picture quality is amazing. There is, however, a downside to this because upscalers like the OSSC are rather costly, and the inexpensive models like the Flylink upscaler that I have also set up that I made a video about a while back are not quite up to the task. They often suffer from input lag and are rather unusable or only usable to an extent when it comes to playing fast-paced games and such. So they are not really a good solution. The OSSC is brilliant and I can definitely recommend it for everything. It supports RGB and component and VGA to an extent, and it's been a good purchase, so I can recommend the OSSC. However, it costs a lot of money. And there is a new solution specifically for the Amigas and for some other systems that comes in the form of this little circuit board in combination with the humble Raspberry Pi Zero, which of course, as you probably know, is like a little single board computer based around an ARM processor that can run software from a microSD card, and it has an HDMI mini output. And there is a new software, or relatively new software, that's called RGBtoHDMI, made by Hoglet67, and that allows this little device to convert RGB inputs coming through these GPIO pins here, to convert that to an HDMI output that can then be displayed on a modern monitor. It is a bare metal software, so it just boots from the microSD and runs without any operating system, so it's self-contained software, which makes it really fast. And it's directly communicating with the processor and the graphics output circuitry that's in here to have very little lag. This project was originally aimed at the BBC Micro of all things, but can of course be adapted to a number of different systems that all have different kinds of RGB outputs. And that's where this comes into play. This little adapter board was made by Copper Dragon, who also did the component out mod for the Commodore 64 that I made a video about a while back. This basically sits in the Denise socket in the Amiga, which is the graphics chip, as you probably know. And then you put the Denise in here and the Raspberry Pi on this socket. And then the Denise signals are converted to HDMI out, which of course is a rather inexpensive and versatile solution to get HDMI out of your Amiga. So this little board has two 74 LVC 574s on it, which are octal D-type flip-flop chips. And this smaller chip is a 74 LVC 86, which is an exclusive OR gate. And this little package is just a voltage regulator that regulates the 5 volts that it gets from the chip socket to the 3.3 volts that these modern chips need as an input voltage. And it's just taking the RGB signals from the Denise, converting them to a format that the Raspberry Pi can understand, and outputting them into the GPIO pins of the Raspberry Pi. And then the magic is happening in the bare metal software on the Raspberry Pi, and the Raspberry Pi should output an HDMI signal through the little mini HDMI port. At the moment this version works with the old style Denise chips, so not the Super Denise. There is a version 2 of this already that can handle the inputs from the Denise too, but it doesn't support the new video modes that the enhanced chipset outputs. So for now, this should be perfectly suitable for an Amiga 500, for example, that has the 48-pin old school Denise and not the Super Denise. For the later models, it is perfectly possible to make an adapter for those, I think, because the Denise has the same outputs, but it comes in a PLCC package, so it's not so easy to build a socket for that. So the plan for today is to put this into my original Amiga 500 and install the software on the SD card in the Raspberry Pi and see what we get. This should technically be a pixel-perfect representation of the Amiga output, and it should have very low lag and very low latency. So yeah, let's see where we get with this. The software as well as the hardware side of this project are open source, so you can download the RGBtoHDMI software that you put on the little SD card, and you can also download the Gerber files to make this adapter board from Copper Dragon's website and from Hoglet's website respectively. If you plan to have your own circuit boards produced for this little project, I can recommend the sponsor for this video, PCBWay, because they are my favorite prototype PCB manufacturer. They also do larger scale projects, but they are perfect for little small scale projects like these and deliver excellent quality, have great service and very reasonable pricing. So check them out. The links are in the video description. Let's try this. So I'm on Copper Dragon's GitHub page now, where he explains a bit more about the Amiga version of the RGBtoHDMI adapter, and he also has a direct link to the software, which also has the bootloader for the Raspberry Pi, which we need. Some of the releases listed on the RGBtoHDMI GitHub don't have the bootloader, which of course won't boot our Raspberry Pi. We need that to run the bare metal software on there. So this is probably the latest version. It's from November 2020, which has the bootloader on there. And I'm going to copy this to our SD card. Of course, this comes as a zip file. You need the boot code bin here. And we are going to copy this, all of these, into the root directory on our card. And then we should be ready to go on the Raspberry Pi side of things. And we have to take a look at the Amiga and how we install the hardware. So I'm now just putting the SD card into the Raspberry Pi. And this should now be able to boot the bare metal software for RGBtoHDMI. Okay, let's open up the Amiga. Been a while since I've been in here. As I said, this is my original Amiga from back in the day that I restored for one of my Christmas specials. Oh, and it has the shielding in, of course. So we're going to have to remove some more screws. Bending some tabs. I think this should now come out. Yeah, here's the insides of my beautiful 1987 Amiga 500, my original one. And there's our Denise chip, which we are going to put our adapter board on. Hopefully it fits. We're going to see. I'm going to remove this chip, put in the adapter socket, put in the chip, and put the Raspberry Pi on top. There we go. So the little notch should be facing this way. Chip goes back on top. Okay, so the Pi actually plugs in like so. And now we should plug in our mini HDMI cable, like so. And that should be it. The newer versions of these adapters actually have a jumper on the bottom side where you can set the Denise you need, but this is a version 1 which only supports these old style Denise chips. So just make sure you set that according to the version of Denise you have. Usually in these old OCS machines you have the OCS Denise, and in the newer, for example, the Amiga 500 Plus and some Amiga 2000s, you have an ECS Super Denise. So this should be powering the adapter and the Denise and the Pi Zero through the original socket. Hope this works. So yeah, I have everything hooked up. Let's see if we get a picture output and if the Raspberry Pi starts up. Oh, look at that. We get a nice rainbow colored output there. Okay. There we go. And it actually works beautifully. We get this startup screen, that's the moment the software starts up. And then we get a crystal clear picture from this. That looks crisp. That looks way better than the OSSC output, which is already really crisp. So that's really impressive. Let's try something a bit more demanding on the hardware. Oh, and I think that actually started up quicker now. Probably it wrote the code to it, which setting it's supposed to use. I'm just trying the regular Turrican tests that I do every time, basically. Okay, and this looks... it is absolutely stunningly sharp. It's really good. Wow. Yeah, this is stunning. This looks like an actual digital output, which it is. Okay, let's see about lag and things like that. This should work with PAL and NTSC Amigas. And for the ECS version, only the ECS resolutions don't quite work yet, but I guess there's going to be workarounds for that pretty soon. And apart from that, who uses the ECS resolutions anyway? I have rarely ever used them. Yeah, it is impressive. I don't feel any lag. Wow. Yeah, Copper Dragon says on his website that it's a couple of milliseconds at most in terms of lag. And it certainly feels like that. Really feels like playing this on a CRT. And I know this game pretty much inside out. I played this a lot. And I recently played it and keep replaying it, keep coming back to it, so it feels really accurate. That is nothing short of impressive. Wow. Okay, and that's an interlaced picture and it's absolutely flicker-free and is displayed beautifully. So that works too. The different resolutions of the OCS chipset supposedly all work. And this looks better than through a regular upscaler because the regular upscalers usually have this interlaced, so it's flickering. And the scrolling is buttery smooth, of course, obviously. Yeah, this is awesome. As this is outputting a 50 Hz signal, some monitors might not quite work with it, unless you have an NTSC Amiga, which of course then outputs a 60 Hz signal. But my monitor plays along nicely, which is good. I get some slight flashing lines there from time to time. Don't know why that is. Probably because I hooked it up through the HDMI input of my upscaler here. We're going to see how this looks through my capturing card in a second. Yeah, unfortunately, we have a slight issue here. My capture card doesn't seem to play too well with the output from our Raspberry Pi here. Yeah, the green on the that you can see on screen is supposed to be black, really. So yeah, it's not quite working correctly. It still outputs the picture fine and the pixels are really crisp, but the colors are off. This is what we get. Not very convincing. Yeah, it still looks pretty smooth, but the colors are off. And we have still, we virtually have no lag at all. The thing might be that it's a 50 Hz output and maybe my capture card doesn't play well with that. But other than that, it works really well. And you can see that the pixels are absolutely crisp and sharp. Yeah, it does still work without any issues with the other setup, just hooking it up to this monitor. So I suppose it's some problem that my capturing card has with the output from this. I tried to fiddle around with the settings and things like that, but I couldn't get it to output a reasonably colored picture, unfortunately. Still, this works as an upscaler for this. One other thing I want to try, the little adapter board actually has a pin header to connect a tactile switch to switch between different screen modes and such in the software. I'm going to try to attach a little button to it. Maybe we can get something out of the capturing card, or rather into the capturing card with a different setting in the software there. Yeah, let's try that. Let's make a little cable and connect a little button to it. So I made a little switch button for this pin header that is on the board, and it's probably not strictly necessary to use because the software sets the screen resolution and such according to what the HDMI tells it. But yeah, maybe it's worth having a look at, and maybe we can get my capturing card to work with this a bit nicer. I left this so long, so I'm going to be able to put it outside of the case in case I want to leave this in an Amiga or just mount it on the case somewhere. And yeah, of course you can also buy cables that have an HDMI socket on one end that you can mount someplace on the case, just leaving this option open with these long cables. You can actually force this to 60 Hz mode by holding the button down on startup, or by just putting a little jumper there on the contacts. Let's try that. Let's see if it actually starts up in 60 Hz. Yes. And with 60 Hz on a PAL machine, you are going to get some tearing and some not so smooth output, because the output from the Amiga, of course, is 50 Hz. So yeah, that's going to be not so great. Okay, so this is booting up fine. We should be able to enter the menu by holding the button for a while. Ah, there we go. Main menu. Okay. Wow, and you can set a lot of options here. Palette, preferences, setting, geometry, sampling. If I hold down the button for a longer time, I'm able to enter the menus. I can put it in scanline mode and all kinds of things. That's pretty nifty. But I'm not a huge fan of simulated scanlines and such. So we could probably work around our issue with the capturing card in the palette menu. But I don't think I want to go into that trouble. We don't have a CPLD. That's the menu update for the CPLD. You can probably update the CPLD code if you use a standalone upscaler for another system. The Amiga version doesn't need this, and it's set to auto set the resolution. Yeah, scaling is auto. Profile is set to Amiga. This is really impressive for what it is. It's just a Raspberry Pi and this little board that I've shown you with the little 74 logic chips on there. So there's not a lot to it in this configuration, and you can save the configuration, of course, and do all kinds of things. Auto calibrate. We can test the monitor for 50 Hz support. What I want to do is to test my capturing card with the 60 Hz forced output by pushing the button during power up. I think that might be a solution for our problem there. Yeah, and in other configurations this can have many more buttons, and I think also you can hook up a little OLED display to it and things like that. I haven't looked into that at all, but you can check it out on the website, and I'm definitely going to check out more options for this RGB to HDMI thing. It seems to be very versatile and it's very cost effective because it's just using a Raspberry Pi and a CPLD, so that's going to be a lot less expensive than off-the-shelf solutions like the OSSC and things like that, and maybe even more versatile. Yeah, unfortunately we get the exact same color mismatch even if I put this in forced 60 Hz output mode. So I guess you would have to fiddle with the palette options there to get this to work right in this setup. I'm not sure if I said thank you to Copper Dragon Reinhardt, who sent this to me for free for checking it out. And there's going to be updates for this. This is a relatively new device. Both the RGB to HDMI project itself and Copper Dragon's adapter are still in development, and I guess there's going to be more incarnations of this. You can buy the little adapter board from Copper Dragon pre-assembled, even if you ask politely. And other than that, you can make your own circuit boards and also your own circuit boards for the RGB to HDMI project, which is something I am going to do eventually, and I am going to check it out for more use cases and more consoles and computers. Seems to support a lot of input signals, and yeah, the quality is just amazing. Yeah, that's it for this video. Thanks for watching. Thanks to everybody who supports my work through Patreon or a channel membership or little donations. Very much appreciated. Hope to see you again on this channel. I'm Jan Beta. Thanks for watching. See you next time. Bye.